Okay, so who am I? So I'm Siddharth Yadav. I study at Triple ITD and I'm pursuing bachelor's in computer science and applied mathematics. So I'm a second year student here, and so what this project is about. So this project is basically about segmenting cell and embryo images of C. elegans. So we'll be getting microscopy images of C. elegans, and then we will be marking the membrane of each cell, or in other words, which will be same as to cell segmentation. And this is the middle. The second one is the kind of the top priority of this Google Summer of Code project. But if type permits, so we will be doing co-registering names with each cell and their size and the shape and position and the velocity vector of each cell with their each cell. So, so this is what what the result would look like. We'll give it an image of the embryo and it will mark the boundaries. This is what I've done till now, and it involves basic edge detection, thresholding, and a few morphological operations. Uh, so, so the one of the most important part of any application is input. What will we provide as an input to this application we are developing? So from user point of view, a user will be able to provide one or several types of microscopy images images or videos for analysis. And for time now, my top priority is to work with TLS SPM microscopy. I was exploring several kind of microscopy images, and I found that it was a lot easier to work with it. So I went it with this one to get it started with this. So these two are some kind of TLS SPIM images which you see, and this one is normal light sheet microscopy, and it is quite hard to work with these one. As you can see, the illumination of the membrane is quite uh, diverse. It is quite spread over the membrane, and the membrane is not so sharp. And the next priority in terms of input would be a general technique for general for fluorescence microscopy. So I would try to develop a technique that would take input any kind of fluorescence microscopy, provided that the cell membrane is stained. That's the second thing I would like to do. And after taking image as an video as an input, there comes the processing part. So what are we going to do with the inputs? So we'll be trying out several kind of segmentation techniques on the images, and this processing phase, figuring out what we do with images, will depend on what kind of input we are giving. And broadly, I will be trying image processing techniques and machine learning methods. And image processing techniques, try out clustering methods, level segmentation, active counters, morphological segmentation, and thresholding method. And the last one is bit, maybe most probably. And the machine learning technique are still not haven't been decided yet. And one of the possible approach we can take in this regard is to label data. And how can we label data? We can label each and every pixel in the image as either it is belonging to a cell membrane or nuclei or background. In this way, where neural network, uh, if we train a neural network using such a data set, it would be able to segment the image in these three categories. And this can be a very, very tedious process, as we will have to label thousands of images, and but it has its pros also, as we are labeling thousands of images, we are creating kind of open data, and it is like available to everyone, and they can develop their uh, network models and techniques, machine learning techniques to do the required segmentation. So, what kind of output are we expecting from this whole uh, application? So, the top priority to do within the summer is to mark the membrane, as I've said before, and it permits to give several kind of quantitative data about it, which is like name, size, as mentioned before. And after we have figured out the technique, what can we doing with the images, the data we are getting, then we have to make an application out of it so that the whole community can use this technique with ease and without much prereq. So the final application can be an ImageJ plugin or a web application, or it might be both. And the choice of uh, environment in which the application will be built depends on of development in that environment, as well as the user experience. The and it will be decided later after the technique is finalized. And while development of the app, I guess in most scientific app, the developer don't keep in mind the UX and UI for the, and I guess I will be giving extra emphasis on that part. And a week, at least a week, will be given to the tutorial and documentation in developing tutorials and documentation for the app, so that the whole community can use it easily. That's it, I guess.
Okay, that looks pretty good. I have a couple of questions. So your let's see, back to your processing slides.
Yeah.
Okay, so let's see. Be trying several kinds. Go to the next processing slide. So this is just kind of a list of things you're going to go through.
I have tried out several ones, like clustering method. I can show a demo also of the clustering one.
Okay.
I tried here is mean shift. So this is, so we can see that in this image the edges are clearly mentioned, like the the area inside the cell, the interior of the cell is of completely different color. So if we use adaptive threshold or multiple threshold, meaning create.
But I think we got that part.
Yes. Yes, there is problem with the signals. Can you hear me?
Yeah, I can hear you.
Okay. So this is the where I get out of mean shift algorithm. So what good in this part image is that the noise is removed by a great extent. You can see that the interior part of each cell is labeled in a different color in each cell. So if we apply adaptive threshold or multiple or threshold with different uh, values, we can be able to separate the membrane very clearly.
Okay.
Then I had this. No, these were some just experiments.
Okay.
And next is
Okay.
and this one I also did this today only. So it was I applied a CAN-EH detector, and after that I applied more operation in a particular sequence to get this image.
Okay. Yeah. Yeah, looks good. So that list there, you're going to basically try
Yeah,
everything and then like maybe bring it down to like a couple of things that like for a sort of a are you going to do like any sort of benchmarking, or are you going to do like just compare them, or how are you going to make your final determination of what works?
so first I will try out each of them individually, like they at except active contours for each one at max will require 3 days, and after that I will either form a sequence of that or try to combine all these techniques to cause individually they don't perform that well.
Okay.
I've uh, tried out thresholding and morphological methods pretty much, but uh, they sometimes don't give nice result. Like there are inaccuracies in many places.
Right.
So
Okay. Let's see. The other
that's what
question. Oh,
mm,
you were. Yeah.
I am trying out level set in active contours because they emphasis on continuous curves, and that is what thresholding and morphological method lack.
Okay. Yeah. Yeah. This looks good. So the next question I had was about the. I think it's the next processing slide where you talk about a strategy for labeling pixels. Yeah, this one. So you're going to label each pixel, or is there like an easier way to do
Yeah.
that?
Labeling each pixel simply says like we mark the a cell
Okay.
like serious. I have an image like this
Yeah.
image. So in this we see that actually, so if we go to a 2D image, so let's this is a better one. So so the black portion in this can be termed as a cell membrane. The portion outside this embryo can be labeled as background, and all the portion inside the cell can be labeled as a cell membrane. So basically, we have to mark these cell membranes and each of the other matter. And to help us in this process, we can use the current method of segmentation to give us approximate cell membrane, which we can edit using which we can edit manually.
Okay.
But it will be a tedious process. Whatever, however,
Yeah.
whatever we do.
So it's for each individual cell, or just that it's a cell membrane? Like, would you just
Uh,
have like an identity for each cell, or like just a made up identity just so you can keep track that like one pixel is in cell membrane A and one is in cell membrane B?
it depends on what we want to get out of that particular machine learning algorithm. If we simply want to segment the cells from different do segmentation, then I guess marking the cell boundaries as a one would be quite sufficient. But if you want to get the name out of the same name or even some more info out of the same neural network, will need to label data in more detail.
Okay.
But I guess doing the cell membrane, marking the cell membrane would be enough because the rest of the data is quite dependent. The lineage is pretty much self-determined, and every else thing is dependent on each other. So
Okay.
we could figure out other stuff in different ways.
Okay. And then the final application, which is down below. I think the app slide.
Yeah.
Yeah. So you had a thought about like a web application. So what would that look like? Would
So
that just be like a display, or would that be?
no. So the reason I put a web application here is so if I want to develop an application in Python.
Okay.
So what would be the best way to develop an application in Python? I guess I can develop an app in Python also, but I was thinking about a RESTful APIs. So a part of community would not be comfortable with RESTful APIs. So I thought giving it as a web application where you can just upload a video and as an output you get whatever you want. So that would be great too.
Yeah, that would be good. Okay. So yeah, this looks good.
Downside of that is yeah. Downside of that would be we could require server space and computational resources.
Right. Right. It says, but yeah, this looks good. Yeah, we can talk a bit more about the app later. And like everything looks good though so far. So you did a good job. And
Thanks.
okay, so and I'll be letting other people in the community have access to this, so they can maybe make comments if they want. And so this will be like,
Sure.
yeah, this will be a record of your like initial project, what you had. And then at the end of the project, we'll do another presentation where you actually put in everything that you've done. So then we can compare them and see what it looks like.
Cool.
Okay. All right. Well, I think we're done
Yes.
for today. Any questions you had?